Ever built a fortress, state-of-the-art defenses, only to forget to lock the doors?
Ouch, that's gotta hurt.
Yeah, that's what it's like to have vulnerabilities in your software.
Makes you shudder, right? And that's exactly why we're diving into the OWASP Top 10 today.
It's like a roadmap of the most critical security risks in web applications today.
Yeah, the OWASP Top 10 comes from the Open Web Application Security Project.
They're a global nonprofit, totally dedicated to making software more secure.
They analyze real-world data, see what vulnerabilities are cropping up, and bam, out pops the top 10.
Super valuable for anyone, really, who's involved in building or maintaining secure software.
Especially in today's world. Okay, so number 1 on the list, we've got broken access control.
94% of applications they tested had some form of this, so.
Yeah, it's the top dog, the biggest threat. Basically, it means unauthorized access to data or functionalities.
So how does this play out in real life?
Yep.
Give us an example.
Imagine someone just messing with a URL, changing an account number, something simple, and boom, they're in someone else's account.
Whoa, like a hacker waltzing through an unlocked door?
Exactly. And that's broken access control, no proper authorization checks.
How do we lock that door then?
Secure coding, that's the key. Principle of least privilege, only give users the bare minimum access they need. And deny by default should be your mantra.
Unless you explicitly grant access, it's a no-go.
Exactly. And remember, server-side code is where the real battle is, not the client side.
Right. Can't forget about those serverless APIs either. Okay, moving on. Cryptographic failures, number 2 on the list.
Yeah, it climbed up from sensitive data exposure, which it used to be.
What changed?
It's about getting to the root of the problem. We're talking about the failures in cryptography itself.
Makes sense. Data exposure is the symptom. Cryptography failure is the cause.
Think about the really sensitive stuff, passwords, financial info, health records. Weak cryptography is often the culprit when those get breached.
So what's the digital equivalent of Fort Knox for our data?
You need data encryption at rest. Even if someone breaks in, they can't read the data.
And don't forget about strong algorithms.
Right. Up-to-date algorithms and protocols are a must. And key management, that's crucial too. How you generate, store, rotate your keys, it's all important.
Got it. Like having a vigilant guard protecting those keys 24/7.
Absolutely. And never underestimate the power of secure protocols like TLS with forward secrecy, all about protecting data in transit.
Okay, so layers of security. It seems like a common theme.
Yeah, definitely. Now let's move on to number 3, injection. Still a biggie, even though it dropped a spot.
94% of applications tested had some injection flaw, you said. Yikes.
Yeah, it's still out there.
Injection attacks. Break it down for us. How do they work?
It's all about injecting malicious code. Could be a form field, a search bar, anything really. And if that code gets processed by the application,
Oh, that's not good.
nope. They could access sensitive data, maybe even take control of the whole system.
Talk about a digital Trojan horse. So how do we protect against that?
Parameterized queries are your friend. They separate the data from the commands, so attackers can't sneak in their nasty code.
Makes sense. So the application doesn't get tricked into executing the bad code.
Exactly. And you need strong server-side input validation, too, like a really strict bouncer at a club.
Only the good data gets in. I
Yeah.
like it. Okay, what's next?
Number 4 is a new category. It's called insecure design. This one's all about baking security in from the start.
Not just slapping it on as an afterthought, but
Precisely. It's like building a house. You need a solid foundation, otherwise the whole thing falls apart.
no matter how pretty the house looks, right?
Right. And it's important to understand the difference between a design flaw and an implementation defect.
Okay, explain that.
So even a secure design can have flaws in how it's implemented, right? But if the design itself is insecure,
There's no fixing that with perfect code.
nope. That's why threat modeling is so important. Figure out the threats, design your application to resist them.
And what about secure design patterns?
Those are like blueprints for building secure systems. And of course, the entire development lifecycle has to embrace security.
Got it. Security is a journey, not a destination. It's about that mindset.
You got it. Now, let's talk about number 5 on the list. Security misconfiguration.
And this one's climbing the charts, right?
Yeah, up to number 5, it's all about the importance of proper configuration management, which is getting tougher with these complex software systems.
More complex software, more ways to mess it up.
You got it. Imagine you've got this state-of-the-art security system, but you leave the default password, rookie mistake.
Ouch. Okay, so what's the solution?
You need a rock-solid hardening process for all your environments. Make sure those security configurations are applied and maintained.
And automate, right?
Absolutely. Automation is your best friend in this game. Now, real-world example. Server with directory listing enabled.
It sounds innocent enough.
Yeah, but it's like leaving your front door wide open. Attackers can browse your server's files, access sensitive data, maybe even reverse engineer your code.
No way. Okay, so configurations, they're the crown jewels. Got it. What's next on the list?
Vulnerable and outdated components come in at number 6.
Sounds self-explanatory, but I bet it's often overlooked.
You're right. It's like driving a car with bald tires and brakes that squeal. You might be fine for a while, but...
But eventually, something's got to give.
Exactly. And in the software world, that give could be a major security breach.
Okay, so how do we avoid that crash?
You need to know your software inside and out. Every component, even the dependencies, got to keep them updated. Tools like OWASP Dependency Check can help.
So it's like meticulous car maintenance, but for software.
Exactly. And neglecting those updates, it can have some serious consequences. Remember that Struts 2 vulnerability a while back?
Yeah, that was a big one. What happened there?
It was a remote code execution vulnerability, all because people were using outdated versions of that Apache Struts framework.
A harsh reminder that patching isn't just about fixing little bugs. It's about staying ahead of the attackers.
You got it. Now, moving on to number 7, identification and authentication failures.
Authentication, making sure it's really you logging in. Sounds simple, but I bet it's not.
You're right, it's a lot more than just usernames and passwords these days.
So what's changed?
We've got automated attacks now, like credential stuffing. They use lists of stolen login info to try and break in.
And weak passwords are still a problem.
Definitely. And those complex password requirements, they often make things worse.
Okay, so what's the solution? How do we step up our authentication game?
Multi-factor authentication, for sure. It's like that extra lock on your door, even if someone gets their hands on your keys.
Makes sense. What about session management?
Another crucial piece of the puzzle. You have to make sure user sessions are handled securely, especially on shared devices.
Right, don't want to make it easy for someone to just walk up and take over.
Exactly. Now let's move on to number 8 on the list, which is software and data integrity failures. This one's new.
New to the list, you mean?
Yeah.
Okay, what's it all about?
It's about ensuring the integrity of your software supply chain. Think about it like this.
Hit me with an analogy.
Okay, imagine you're using ingredients for a recipe, but you got those ingredients from, well, a questionable source.
You can't be sure what you're actually putting in your food.
Exactly. And it's the same with software. You need to know it's coming from a trustworthy source, that it hasn't been tampered with.
Okay, so how do we do that? How do we verify our ingredients, so to speak?
Digital signatures, that's one way. They help you make sure the software is authentic and hasn't been messed with. Then there's insecure deserialization.
That's a mouthful.
It's a vulnerability that allows attackers to sneak in malicious code by exploiting how data gets processed.
Okay, so it's like someone tampering with your ingredients when you're not looking.
Exactly. And the source material actually had a good example about this. It involved a React application and some Spring Boot microservices.
What happened?
Well, the developers wanted to keep their code immutable. Generally a good practice, but the way they were serializing and passing user data back and forth.
It created a vulnerability.
Yep, essentially. It gave attackers an opening to mess with the data and potentially inject that bad code.
The SolarWinds attack from a few years ago really highlighted those software supply chain risks. What was the big takeaway from that, in your opinion?
Trust your sources. And be very, very careful about what components you bring into your environment. If you can, host an internal repository of vetted components.
Control what you can control, right?
Exactly.
Okay, so we've covered securing the software supply chain. Phew, it sounds like a constant battle.
It is. But that's cybersecurity for you. Now let's switch gears a bit. We're going to talk about security logging and monitoring failures.
Back on the list, huh? I guess it's important.
Definitely important. I mean, you can't defend against what you can't see.
True enough. So give us the rundown on effective logging and monitoring. What are the key principles here?
All right, so you got to log everything important, every single event. Then you need to be monitoring those logs, looking for any suspicious activity,
Makes sense. Be on the lookout for anything fishy.
Exactly. But the most important thing, have an incident response plan.
So it's not enough to just see what's happening. You have to know what to do when something goes wrong.
Exactly. And you wouldn't believe how often organizations mess this up. They might not log enough information, or they don't analyze it properly.
Or they don't have a plan at all.
You got it. And then something like that data breach happens, the one with the children's health plan provider.
Yeah, I remember that from the source material. What happened there?
Millions of records compromised, all because they weren't logging and monitoring properly. It went undetected for years.
Yikes, that's a scary thought. Okay, let's move on to the last one on the OWASP Top 10 Server-Side Request Forgery. SSRF, right?
Yep, SSRF. Brand new entry on the list. This is when attackers trick your server into fetching things it shouldn't.
Okay, how do they do that? Give us an example.
Imagine a hacker sends this forged request, right?
Right.
And it makes your server grab sensitive information from a totally different system. Could even be behind a firewall.
So they're using your own server against you.
Exactly. SSRF can be used to scan internal networks, steal data, you name it.
Okay, that's pretty serious. So how do we protect ourselves from that? How do we stop our servers from being hijacked?
You got to validate everything, user-supplied URLs. You need to be super strict, make sure they're legit.
So don't just react to every bad URL. It's about setting those boundaries proactively.
Exactly. And like with most of these vulnerabilities, a layered defense is key. Don't just rely on one thing.
Got it. Multiple layers of protection make it as hard as possible for those attackers. Okay, so we talked about all 10 vulnerabilities now, but OWASP is more than just a list, right? Tell us about some of the resources they offer. How can they actually help organizations improve their security?
They're all about solutions. Free resources, galore cheat sheets, presentations, even books. All about secure coding, code review, you name it.
Sounds like they've got everything but the superhero cape.
Right. The cheat sheet series is really good, especially for beginners. It breaks down complex topics into easy-to-understand guides.
Handy to have on hand.
Definitely. And they even have specific cheat sheets for different programming languages and frameworks.
Nice. So if someone wants to dig deeper into the world of OWASP, where should they go?
Their website. It's packed with info, latest research, community forums, all that good stuff. You can find tools, documentation, videos, tons of resources.
And it's all free, right?
All free. OWASP's a nonprofit, so they're all about making this knowledge accessible.
Awesome. So we've talked about the top 10 vulnerabilities and the resources they provide, but let's take a step back and talk about the bigger picture. Why is OWASP so important? What impact do they have on the cybersecurity landscape?
They're all about making software security, like, visible, actionable, and approachable. They're not just talking to the experts. They're talking to developers, business leaders, everyone.
So it's a reminder that security is everyone's responsibility, not just a specialized team.
Absolutely. And they're really bridging that gap between security pros and the wider tech community, making knowledge accessible, helping everyone build safer software.
And they're open source, which is huge. It's all about sharing that knowledge and working together.
That's the best part. It's not just about knowledge either. They actually develop a bunch of open source security tools. The Z-Attack proxy, ZAP for short, it's for penetration testing, and the dependency check, which we talked about earlier.
So they're not just talking the talk, they're walking the walk too.
Exactly. They're all about empowering people and organizations to take control of their own security.
Okay, let's shift gears a bit. Let's talk about how the OWASP Top 10 is actually put together. How do they decide what makes the list?
Yeah, I'm curious about that too. It can't just be based on what's trending on Twitter, right? It's got to be more scientific than that.
Oh, definitely. They're super rigorous about it. It's all data-driven. They take real-world data from security testing, combine it with insights from the community. So it's a mix of hard data and expert opinions. And what kind of data are they looking for? How do they analyze it all?
They're mainly focused on how prevalent each vulnerability is. How widespread is this thing in the real world? So they look at things like how many applications were tested for a specific vulnerability and what percentage of those applications actually had it.
So it's not about how many times they find a vulnerability in one app. It's about how many apps are vulnerable to it in general.
Exactly. They want to understand the overall risk to the entire landscape.
So to summarize, they gather all this data, analyze it, figure out which vulnerabilities are most common, and then use that to create the OWASP Top 10 list.
Yeah, that's the basic process. But they also take into account how impactful each vulnerability is.
Right, because a vulnerability might not be super common, but if it's exploited, it could have a huge impact.
Exactly. So they pull data from vulnerability databases like the NVD. That helps them understand how exploitable each weakness is and what the potential damage could be.
So it's about balancing the likelihood of a vulnerability being exploited with the severity of the potential consequences, right?
Exactly. And they also get feedback from the community, like surveys and stuff. They want to know which vulnerabilities are top of mind for people in the field.
So it's a collaborative effort.
Yeah.
Data analysis plus expert insight.
Exactly. And it works. The OWASP Top 10 has helped so many organizations improve their security.
It's a great starting point, but it's just the beginning of the journey, right? Security is an ongoing process.
Couldn't have said it better myself. Security is definitely not a one-and-done deal.
The OWASP Top 10 is a fantastic roadmap, but it's up to us to take those insights and put them into practice. We need to be proactive, we need to be informed, and we need to keep learning and evolving.
Absolutely. And you need to foster that culture of security within organizations. Everyone needs to understand that building secure software is crucial.
So let's talk about that. Building a strong security culture. What can organizations do to make security a part of their DNA? Where do they start?
First things first, security has to be part of the development process from day one. No afterthoughts, no tacking it on at the end.
Security by design. Bake it right into the cake.
Exactly. You have to include security professionals in the design and planning stages.
So shift security left. Make it part of the whole development pipeline.
You got it. And give developers the training and tools they need to write secure code.
So it's about empowering everyone, not just relying on a dedicated security team.
Exactly. Developers are on the front line, so they need to be equipped to handle security risks.
Okay, what else is important for building a solid security culture? What are some of the key elements?
Communication is huge. Everyone needs to be on the same page. Developers, security pros, business leaders, everyone has to understand that security matters.
Break down those silos and work together.
Exactly. And when a team does something good, like they find and fix a vulnerability, you got to celebrate that.
That's a great point. Make it a positive thing. Celebrate the wins.
Exactly. Make people feel comfortable talking about security, asking for help when they need it.
It's a team effort, not a burden.
That's the mindset.
So we've covered a ton of ground today, from broken access control to, what was it?
Server-side request forgery.
That's the one, SSRF. It's amazing how OAuth takes all these complex issues and boils them down into a list anyone can understand.
Right. It's really a testament to the power of community. Speaking of community, I think our listeners might be wondering how they can get involved with the WASP, be part of this whole movement.
Definitely. A rising tide lifts all boats, right? The more people we have fighting for a safer digital world, the better.
Absolutely. And OWASP thrives on those passionate individuals. Doesn't matter if you're a seasoned security pro, a new developer, or just someone who cares about making the internet safer. There's room for everyone.
Okay, so how can they get involved? What are some concrete steps they can take?
Well, joining your local OWASP chapter is a great place to start. They have meetings, workshops, conferences.
It's like a security superhero meetup.
I love that. And if you're feeling a little more adventurous, you can always contribute to OWASP projects directly.
What kind of projects are we talking about?
There are tons. Developing secure coding guidelines, creating open source security tools, all sorts of things.
You can actually get your hands dirty, so to speak, and help build the resources that make the internet a safer place.
Exactly. And even if you're not a coder, there's still a lot you can do. OWASP needs help with documentation, translations, research, even just spreading the word about application security is important.
It's great that anyone can contribute, no matter their skill set.
That's the beauty of OWASP. They really believe in the power of community. It shows you that, we can tackle these complex challenges if we work together.
It's inspiring. Okay, so we've talked about the OWASP Top 10, the resources they offer, how to get involved. We even touched on building a strong security culture. Before we wrap up, I want to leave our listeners with something to think about, a challenge, if you will.
I'm all ears. What's the challenge?
I want you to pick one vulnerability from the OWASP Top 10. Whichever one resonated with you the most, or maybe the one that you think is most relevant to your work.
Okay, I like it so far.
And then I want you to spend some time this week really digging into it. Read the OWASP documentation, look at the resources we mentioned, maybe even play around with some of the open source security tools.
That's a great idea. It's one thing to know about these vulnerabilities, but it's another thing to actually do something about them.
Exactly. The goal is to empower you, the listener, to take action, to become an active part of making the digital world more secure.
Yeah, put that knowledge into practice.
Well, that wraps up our deep dive into the OWASP Top 10. Security is a journey, not a destination. So stay curious, stay vigilant, and most importantly, keep learning. And let's build a safer digital world together.
Couldn't have said it better myself. Stay secure, everyone.